Post understanding any kind of field, gravitational field, electrical field, magnetic field, the next natural thing for us to understand is potential energy. So first thing is, let's recall a few things about potential energy. Potential energy is another name for your stored energy. And stored energy, here the energy is mainly in the form of configuration. Generally, we classify it as, when we were kids, we classified it as configuration and position. So one of the possible example is your gravitational potential energy, right? So basically, let's recall what is gravitational potential energy. If this is Earth's surface, and if I have the object over here, if I have an object over here, and another object of the same mass, so this is say 3 kg and 3 kg, this is said to have higher potential energy than this. Agree? Right? Okay. See, before we start off, there's a very important concept that I would want to discuss before I dive in to the actual definition and everything. Something called as a reference line, guys. See, reference line is a position wherein things stays as it is. For example, I'll take spring. Let me consider this to be a frictionless. So if I take up a spring and I have this setup and I have a mass. So this position, say point A, and if there's no external force acting on it, the net force on it is 0. And if this is at rest, if all of this condition is satisfied, then I can tell that point A or position A is the natural zero for this system, for the above system. Again, it's a language, it's a way to communicate that nothing happens if I let the system be. So this is your reference line. So point A is your reference point or reference line for the above system. So similar to this, okay, so this is an example. So next is for gravity. Can you guys guess where the natural zero is? Say this is an object. Where do you think the natural zero is? Any idea? It's at infinity. So when it comes to gravity, the natural zero is at infinity. So why? It's obvious, right? Anywhere else, if you take up the formula, right? Let me take up the formula. F is equal to G m by r square. So anywhere else before infinity, r is a finite value. And if it's finite, means if it's non-zero, then it will start falling towards this particular object at infinity, right? So f of infinity. So if I'm taking this as a function of radius, f of infinity will be 0. So anything divided by infinity is approximately 0. So our natural zero is infinity. Our reference line or the reference point is infinity. This has to be very clear. So with that as our reference point or line, so if I want to define the potential energy at say point A over here, so it's quite simple. All I have to do is carry an object, say potential energy at point A because of for an object of mass m. So this is a case. Sorry, I'm kind of stuffing things in. So potential energy specific to gravity for an object at A, and the mass of the object is mass is m, right? Within this sphere of influence. So because of this object's gravitational field at point A will be the following. All you have to do is carry the object from infinity to point A. The amount of work that we do in carrying the object from point B to A, B being at infinity. So this is at infinity, and this is at infinity, and this is at R. So the work that we do from carrying an object from point B to point A is the potential energy at point A for this particular object with mass m. Gravitational potential energy for an object with mass m at A. So this being the case, this will be your answer. So I'll consider this radius to be r, radius of this planet. Then math gives us potential energy at A for an object with mass m for this particular gravitational field will be minus g m small m by r. So this is valid only for r being greater than small r being greater than capital R. So basically, if I can figure out the potential energy at any point outside this planet using this formula. Okay, so this is from me. Let's see the write-up. The gravitational potential energy, first thing is potential energy. The basic idea is a stored energy because of position configuration. Reference line is every potential energy needs a reference line. For example, spring, 0 at natural length. And for gravity, it's at infinity. So why infinity though? Gravity becomes weaker as distance increases. Only at infinity separation does gravitational force becomes 0. So it is natural to choose u of infinity is equal to 0. So basic idea is that gravitational potential energy is like stored up energy waiting to be released by gravity. So it's all about position. So yeah, we can have a better official definition. I think I can change this. Work done to bring a body from infinity to a distance r is the potential energy at that point. Okay, this is not a great definition, guys. So you can do a better job. So potential energy at a point A carrying a mass of m is a measure of amount of work done in bringing a body from infinity to a given point in that gravitational field. You can define it something like that. So the potential energy is the property of a system of two particles rather than of either particle alone. So this is a small note. The potential energy idea exists because both the particles are present. So it's indirectly talking about this. Let me give you guys a more practical scenario for that note. Changing the color. Say it's this. Which is more scary? You have your hand. And you have a pencil above your hand. In one case, I have a pencil a meter above your hand. And in another case, a meter above your hand, I have a bowling ball. Which is more scary? Are both same? No, right? Both are not the same. This is obviously more scary than this. Is it not? So this is more scary. This is a no-no. This is okay. No one would prefer anything. But yeah, for fun, a pencil from that height, it's okay. So basically, it's not only that Earth's gravity is influencing this scenario, right? We are on the surface of the Earth. So Earth is your first M, capital M. The small m also plays a role. So this is M1, this is M2. So M2, if it's obviously it's greater than M1. So this is a no-no scenario. So that is what we are trying to put it in fancy words over here. So basically the potential energy in the second case is much more than case 1. Potential energy is the property of system of 2 particles. It's not just one. While the field was just one, right? Field is to do with the objects. It's because of the objects present. That's it. Potential energy is because of 2 things being present, right? 2 things which present within the space wherein they can influence each other. Now, finally, expression for gravitational potential energy is this, and yeah, we are done. So you guys can see what you would like to write.